Okay, so 1-1, angles, degrees, and special triangles. This is your review of geometry, what you need to remember. We're going to spend 2 days on this section just because I want you guys to have the repetition. Now, your assignments may look like they're huge amount of problems, but they should be very quick problems. If when they start taking you longer, you'll have fewer problems. Okay, so we need to talk about an angle first. What an angle actually is an initial side and then the angle is actually showing movement. Okay, so this is where the ray started and then it moves, and so it terminates here, so it's called the terminant side. A terminal, excuse me, not terminant. We call angles in general theta, a circle with a line drawn through it. Any Greek symbol can be used. We tend to use theta the most, alpha, then beta. So we have theta, alpha, beta.
How do you draw that symbol? Like a little fish.
Yeah.
So we're going to use all those?
Yes.
Great.
Okay. Theta, again, is the one we will use the most.
Theta.
Let's see if I can do this. I got it.
Okay.
Professional. Let's see.
I think.
Is that an E or an A?
Okay. Cursive.
Cursive.
That's
The second one's alpha?
yes.
And then beta?
Beta. Yep. A, B, C. Or A. Alpha is A. Beta is B.
Is the B just a B with an A?
Yes. Okay. So when we talk about angles, when they we did talk about this when in geometry, but I don't know if you really remembered much.
No. I sucked at geometry, so
If I go
I
counterclockwise,
didn't try.
it is positive. Okay, counterclockwise is positive. Think of it as rising. If it rises, it would go counterclockwise, wouldn't it? Positive angle. If it falls, it is negative. Now, I hope you notice that I'm putting arrows on the arcs, correct? Those are important. They show direction. So we're going to do a triangles and circles, and hopefully you'll be able to draw an amazing circle like that. So we have a center of the circle. We have the initial ray. And if we go all the way around, so it's one complete revolution. Is how many degrees?
360.
Wow, that's quite the circle I just drew.
Okay. So 360 degrees is one complete revolution. We will have half of a revolution, which would be how much? 180. We will have a quarter of a revolution, which would be 90. We have 3/4, which would be 270. Those will be our main ones because they will fall if I finish this and if I finish this. What did I just put on that?
Slices.
Did I not put a coordinate plane on there?
That's included.
We don't know what the frig that is.
Yes, you do.
Oh.
X and Y, a coordinate plane.
Use
Okay.
X and Y, not your fancy terms.
So we will be putting circles and triangles and coordinate planes, and we will be imagining them on application problems. So the whole point of this is to apply it. So that's what we will work towards every time. We need to remember words like supplementary.
I remember that word. I don't remember it.
Supplementary angles have a sum of what?
Mm-hmm.
180.
Mm-hmm. If you remember supplementary, do you remember the other word with it?
Complementary.
Complementary. And complementary angles have the sum of,
Is it 360 by chance?
nope,
180.
90.
90.
Yeah.
And these are pairs of angles. So how many angles is that?
2.
Okay. So you don't name 3 angles as being complementary. Does that make sense?
Yeah.
Okay. So we have some special kinds of angles that we need to remember also.
We're going to do the obtuse.
So this is a what angle?
Right.
Right angle. And what's special about a right angle?
Perfect
90
90.
degrees. And how did you know this was a right angle without me doing anything
The
else?
square.
The square. And the square has to be there. Okay, you can't say, oh, it looks 90 degrees. Got it? What's this one?
A straight angle.
A straight angle. Well, it would be supplementary if I had 2 angles. Does that make sense? Supplementary is the sum of 2 angles. So this one is just a straight angle.
Isn't that 180?
It is 180 degrees. Supplementary angles can also be called linear pairs because they make a line, and linear means line. Okay? How would you describe this angle with no measurement on it? Acute. Because it is what? But what's the definition?
Less than 90.
Less than 90.
That's obtuse.
And that's obtuse. And it is
Greater.
and get used to putting your degrees on everything now. Only angles though. Don't put it on side lengths and stuff. Because I do go around taking off half points for it. So how would we draw a picture of complementary angles? What does complementary mean?
They have a sum of 90.
And they are how many angles? 2. So how would we draw a picture of that? There's a 90-degree angle.
Could we just do two acute?
Just do 2 acute angles. So you draw this, right? And just make some, and I've divided one angle into 2 angles. So what I know, those 2 are complementary. With no words or numbers. Okay.
Which ones? Oh,
Because there's one angle here and one angle here.
That's a compliment.
Mm-hmm. And it's 2 angles, and that's the symbol for angle, yes, that equal 90. Okay, so how would I draw supplementary? Oh, wait, just a second. Let me do something. We would name this one like alpha and this one beta.
Why can't we just use A's and B's?
Because we don't. Greek has been around a lot longer than English. Okay, how would I draw supplementary?
2 angles are equal.
So I do a straight angle and divide it, like draw another angle, right?
You can put like 2 90s.
You could put 2 90s, but then your brain would think it always has to be 2 90s. Does that make sense?
Yeah. Oh, I did it the other way.
That's fine. So this is alpha now. And this is beta. And they're supplementary. And there are 2 angles. And when you draw that symbol, you have to have arrows if you want it to be an angle that equal 180.
That's a lot of pictures.
Yep, it is. You will draw pictures all the time. Okay, so if I gave you an angle, 87, and I wanted the complementary and the supplementary. How would you find them?
Back to
So you guys know I'm big on showing work, so you got to give me 90 minus 87, so the complementary is 3 degrees. And how would I find supplementary?
180.
So 180 minus 87. So if I round that to 93. So all complementary angles how do you find them?
subtract.
Subtract the first angle minus 90.
Subtract the total from what angle you have.
Well, you 90 minus the angle you have.
Yeah.
90 minus theta. And how do you find all supplementary?
180 minus.
180. The theta. Now, did I say it had to be positive? Nope. What if I had 200? What would be my supplementary?
-20.
-20.
Can you have a negative angle though?
Yep, because remember, if you go the
Oh.
opposite direction, we can have a negative angle now. Now, can I have a negative angle in a triangle?
No.
No. But when I'm talking, when I take that into the real world in an application problem, can I have a negative angle? Yes. Okay. A lot of vocabulary today, just to refresh all of that for you. So we need to talk about some triangles because it was special triangles, yes?
Yeah.
What kind of a triangle did I just make?
I don't know the size of triangles.
Nope.
That's the only triangle I know right
Well, you don't know it because
Right.
nope.
No, it's not.
What do you know about this triangle?
now. All the sides are, all the angles are. So
All
it's
the angles are equal and all the
Equilateral.
equilateral, also known as an equal angular.
I don't like
Okay, we are probably not gonna refer to it ever as that, but it equal angular also.
I don't want to spell equilateral.
I'm spelling it for you. Okay,
It's not very.
so it's equilateral, and if it's equilateral, then it's equal angular. And then what is every single angle equal?
What did you just ask me?
If it's equilateral, it's equal angular, and every lateral triangle has the same measure of angles. What is that?
45.
Nope.
120.
90.
Nope. How many degrees is in a triangle, guys?
45. No.
How many?
I thought it was 360.
Not in a triangle.
Is it 180?
180. So it's 180, and all the angles are the same.
60. No.
Yes.
Yeah.
So every equilateral triangle, all the angles are what?
60.
60. Does it matter how big the sides are?
No.
No.
Is that this one you just said, Emma?
That's the isosceles.
This is isosceles because why?
Two of them are
Two sides are equal. Remember, and well, we're going to say congruent because we don't know lengths, right? So it is an isosceles. Okay, and the angles across from the congruent sides are also what?
They're equal.
Congruent. Okay, objects are congruent, lengths are equal. Does everyone get that?
Yeah.
So I don't have a length, so I can't say equal, but I can say congruent. So do the words basically mean the same? Yes, but objects are congruent, actual measurements are equal. Okay, so what triangle are we missing?
The right.
The right triangle.
Well, you could, but
What?
the scalene triangle.
Nobody calls it that.
Well, that's what it's called, so I'm sure everyone does.
What the heck is
No.
that?
Okay,
It's ugly. Oh, wait. That's not the one I was thinking of.
okay, scalene, what does it mean?
None of the sides are equal.
None of the sides are equal. See, someday you'll be as good an artist as I am. Okay, so an isosceles triangle can also be a what triangle? What do you notice about all these angles?
They look the same.
Okay, how would you describe those angles of those triangles?
Congruent.
We have these. How would you describe those angles of that triangle?
They're all acute.
Acute. They're all acute. Angles. So it's a what triangle?
Acute.
An acute triangle. Okay. So we got an acute triangle. Then we also need a
Right.
Obtuse.
Obtuse. We'll get to the right one. You guys all know that one. I'm not worried about it.
How do you make an obtuse one?
You make an obtuse angle. Because this... Now, how many obtuse angles are in an obtuse triangle? One. There can only be one. Because all triangles, the angles add up to what? 180. Can there be two obtuse triangles in a triangle? No, because two angles over 90 would be over 180, wouldn't it? Okay, one obtuse angle. So it's an obtuse triangle. Now we'll get your what?
Right.
Right. Can a right triangle be a scalene triangle?
Yeah.
Yes. Can a right triangle be an isosceles triangle?
Yeah.
Can a right triangle be an equilateral triangle?
Yeah. No.
No, because what are all the angles in an equilateral? 60. Okay, how do I make this a right triangle?
When it has a right.
So is it a right triangle yet?
No.
Nope. So I have to either put 90 there or the... See, you guys remember more than you thought.
Yeah, but I'm not good at this.
Okay, so you'll get good at it.
So I can remember the little triangles.
Am I good to move it up? Okay, so we have the wonderful thing that you can only use on right triangles.
Pythagorean theorem.
I forgot about that.
That's a hard word forever.
And we need to put in big bold letters, only use on what?
Right triangles.
Okay, so what is the Pythagorean theorem?
Isn't it a squared plus b squared plus c squared?
Yep, a squared plus b squared equals c squared.
Yeah.
Now, a squared plus b squared equals c squared. Okay, what are a and b of this triangle? They specific names. Well, what's c?
That's the hippo thing. Isn't it? Or is that the like?
I want the real word. What's c?
Line.
It does start with h. Describe the placement of c.
Top. Opposite.
It could be the bottom. What?
Opposite of the
It's opposite of the 90-degree angle. It is called the
90. I don't remember what it's called. I knew it.
high hypotenuse.
Yes.
See, I was close.
Okay, that was in my mind. No,
I couldn't remember how to say
stupid
it.
if I said it out loud.
Okay?
The hippo thing.
So what are A and B?
Non-hypotenuse.
They're legs.
Oh.
A and B are the legs, they make the right triangle. C is the longest side. Yes? So could I write this as legs squared
Bless you.
plus legs squared equals the hypotenuse squared?
Sure.
Because is the hypotenuse always going to be named C? No. And we get these names because this would be angle C, this would be angle A, and this would be angle B.
Dude, I was-
Angles are labeled with capital letters, sides are labeled with lowercase English letters. Okay? Now, the angle is opposite the side. Does everyone see that? That's important because if you don't label a triangle right, are you going to be able to solve it right? No. Okay? When I do this, if I want A, I'd subtract B, take the square root, correct? If I want B, I would subtract A, take the square root. If I want C, I'd have to take the square root. Okay, so you guys know how to solve an equation, yes? Okay, one last thing we're going to do before we go today. And you're just going to be applying this to different things in your, is area of a triangle. Now, before we do this, we are going to think about it. What area do you know off the top of your head of any shape? What shape's area could you just like spew out to me quick?
Square.
A square or a rectangle, yes? So if I have a rectangle, could you make a triangle?
Yeah, cut it in half.
Can you cut it in half? Yeah. So the area of this is length times width, yes? So the area of a triangle is 1/2. Why is it 1/2?
Because you cut it in half.
You cut it in half. And we're going to say base times height. Can that be length and width? Okay. So now, will you ever forget a triangle?
The height of the vertices.
Yes, if you want. Okay. So, you have everything you need to do your assignment for today. Any questions? I really need you guys doing your assignments every day so you can answer your questions so we can move to the next thing. None of this is in a vacuum. What we learned today, you will use every single day from the end of the semester.
Okay.
And I'm not joking.